Extract function is a really useful refactoring. It can help to make your code more readable and easier to test, at the same time as letting you reduce duplication. Any refactoring tool that's worth the name will include extract function or extract method, and that means it'll be an automated atomic transformation that should be safe and quick to do. It's really worth becoming fluent with this technique and understand all the options your tool presents you with. I think it's also worth knowing how to do it by hand without a tool if you need to. In this learning hour, we're going to look more closely at extract function and how to make the most of it, for the benefit of your code health. Hi, I'm Emily Bache, software developer and creator of Saman Coaching. In my channel, I have content for developers and technical coaches. If you like what you see here, please hit subscribe and like. You can get more help and supporting materials, including the online whiteboard that we're using in this session, if you subscribe to my Patreon. This is a guided learning hour, and that means it's a training designed to be done together with the whole development team. Any individual developer who's interested and enthusiastic about code quality and refactoring should be able to lead this session, with a little help from me. This is the point in the video where the actual session is about to start. So later, when your team is all gathered, you can just go straight to the chapter, Gather Your Team. But first, you probably need to prepare. Watch the whole video first, including the Facilitator's Briefing, which is near the end. Hi, I'm Emily Bache. Welcome to this guided learning hour. I'm going to take you through this session together with your facilitator. The focus today is on the extract function refactoring, and we're going to be using this online whiteboard that everyone should have access to. First, a warm-up question. Why might you prefer to have several shorter functions instead of one longer one? Raise your hand if you have an idea, and your facilitator will write what you say on a note. See if you can come up with 3 or 4 reasons why you might want several shorter functions instead of one longer one. Well, I don't know what you've written, but these are reasons that some people often say about this. Shorter functions are easier to read generally than longer ones, so having several shorter functions could make your code easier to read. And another reason to do it could be that you can make a function that you can call from several places instead of duplicating that code in all those places. And you've probably come up with other things as well. There is one very particular reason for having several shorter functions that I think is a really killer argument. I'm going to tell you what that is in a minute. I wonder if you've got it. What we're talking about here today is extract function. This is when you take one of those longer functions and you split it up. You take a piece of it, a paragraph, and you extract that into its own function named after its purpose. And the refactoring is also known as extract method. It's basically the same thing. The only difference is whether you're extracting a piece of a method that turns into a new method or a piece of a function that would turn into a new function. And sometimes you start with a method and extract a function. It's basically the same refactoring. So in the initial warm-up discussion, I had you coming up with reasons you would like to have shorter functions rather than longer ones. And this is basically the reasons why you want to do extract function, so that you get better readability and you don't have to duplicate code. But there is another reason, which is really the reason you do this. The killer reason for doing extract function is so you can separate the intention from the implementation. So there's an example on the screen here. This is a little function called isTie, and the implementation here is it's going to check if the 2 players have the same score. So that's the implementation. But what you've added when you've done the extract function is the intention. The name of this function is isTie. It returns a Boolean. So now when you're reading the longer function that this came from, you can see the intention of this piece of code just by reading the method name. And that means potentially you don't need to read the implementation. And that makes your code easier to read and understand and reason about. This is a piece of code that comes from the cache machine refactoring kata that we did in a previous guided learning hour. And I noticed one pair made a mistake with one of the extract methods, and they ended up with a signature looking like this. So the implementation, the first line of the implementation finds a branch for a town using two of the arguments that were passed in. The function find branch for town and the town string. So you've got this strange kind of argument list here, which has got these two kind of redundant things. What you actually intended to do here was extract a method that had the branch as an argument, and they haven't achieved that. So they've ended up with a method that really doesn't make sense. The intention of this is not clear, and to understand what it does, you'd probably go and read the implementation, which kind of defies the point. So it's actually quite important to pick the right section of code to extract. So I've got a little exercise for you here. This is the tennis game 6 from the tennis refactoring kata. And I've got a box here, so you can have a little closer look at the code and decide, which section of code would make sense here to try and extract as a function. And there's probably more than one. So I'd like you to spend a few minutes now looking at this and see what would you extract as a function in this piece of code. Okay, so I hope you've had a good discussion about identifying suitable pieces to extract. Now, I just had some ideas for you here. So one thing that jumped out at me was these two switch statements towards the end of the function. There's some duplication here, and I think it would make sense to extract a function that could do both of these pieces of code instead of writing it out here. And then when I looked a little bit more wider, there's these comments here and there, like this comment here, regular score. That implies to me that there's a section of code here that might make sense to extract as a function called regular score. In fact, there's several of those. So there's another one here called endgame score with I could put a box around that piece. And this part here, tie score. So one of the signs that you've got a paragraph that would make sense to extract is that kind of comment. So that's one thing to look for. Duplication is another. Let me demo for you how to use a refactoring tool to extract those functions. In this demo, I'm going to use Rider and C#. You'll find very similar functionality in ReSharper. But not everyone is using these kinds of power tools. So I'm also going to show you how to do this refactoring safely without any tools at all. In both cases, I want you to pay close attention to how I'm doing this, how I work in small, deliberate steps to reduce the chance of introducing any errors. This is the tennis game 6 exercise and the get score method that we looked at just now. I had you look through this code and try and identify some paragraphs that we can extract as functions, and that's what we're going to do now. It's quite a long method, and there are 3 very obvious paragraphs, actually. We've got very good tests, so if we make any refactoring mistakes, they should fail and tell us. Okay, so the first paragraph here, tie score. I'm just going to select all that code and call my tool to extract method. Even gives it a good name. There, and it's done it. That wasn't too hard. There's the code. There's the call to my new method. And here's the definition of that new method. That all looks like it's all working. Okay. I think I might just inline that variable there. It wasn't doing much. Check all my tests are still passing. Okay, so now endgame score. This is the next paragraph we identified that we might like to extract. So I'm just going to select all of that and use my tool. Extract method. This method should be called endgame score, I think. Great, so it did that for me very easily. And now getScore has got the first 2 paragraphs each extracted. And the endgame score is over here. It's done something a bit strange there. It's introduced a result variable. Let's see if I can inline that. Oh, I didn't want to. Sometimes with inline, it's a little bit picky about where you put the cursor. Didn't like it there either. try this. Now it worked. For some reason, inline only liked to inline it from one place. I don't know why. But now result is gone and we've just got endgame score. Good, so that's code is starting to look okay. Now, what about this third paragraph that we were thinking to extract? Regular score. It's the same procedure. I highlight all of this code. I'm not using the mouse, actually. I'm using extend selection, which I find very useful. And there we go. I'm going to name this new method regular score. Excellent. So now the get score method is looking pretty good. It's just got 3 sections, each with their own method. And regular score, though, I think we can do some more here. Again, I've got that result variable again. Now I know how to get rid of it with inline. But now I've got this duplication. I should just check all my tests are happy before I do any more. Yeah, so score 1 and score 2 are very similar. I'm just going to extract methods for those 2 pieces and then worry about whether I can combine them. So first, I need a name for this. Score name. Yeah, the name of the score should be love or 15 or something. Yeah, maybe that's a good name. And I'm going to do the same for the other section that I think is probably duplication, that I could have the same function in a minute. So I'm just going to call this score name 2 to kind of signify that they're actually doing fairly much the same thing. So now I've got these 2 extracted. It's a good idea to have a closer look at them. I'm going to use my tool here to compare them. The first thing I do is copy one of them into the clipboard, and then I'm going to highlight the other one of them. And when I right-click, I get a menu which has gone off the screen. So try that again. Right-click. There. Compare with clipboard. That's the option I want. That's the one that's, because I already copied the other one first. Now I get up this nice little diff window that shows me exactly how much of this code is duplicated. And I can see actually, apart from the method name, which obviously has to be different, it's only what we're switching on that differs between these 2 snippets of code. So that shows me that actually if I could extract that as a parameter to this function, then they would be the same. So let's see if we can do that. Extract parameter is another very useful refactoring. Put the cursor there, use my tool, extract parameter, or it's called introduce parameter, and the name of the parameter score. So now I've got a parameter to this method. And I can do the same with the other one. I'll also call that one score. And then I'm going to do the trick with comparing with clipboard again and check that they are now identical. Because I always want to make sure that my refactoring is as safe as possible. And by using my tools like this, I reduce the chance of me making any kind of mistake. So good. So now it's just the method name that's different. So I should be able to use one in place of the other. So let's use score name in both places. And run the tests, because that was a refactoring by hand now. I'm pretty confident and the tests have passed, so now I just need to remove this unused method. And I've got rid of that duplication. Looking at this now, I'm thinking, it might be nice to inline those. These score 1 and score 2 variables aren't doing much. And then regular score, I can join the declaration and assignment, and then, well, let's inline it. Yeah, so this is starting to look very concise, actually, and hopefully easier to read than it was before. So I'm just now looking over the code, looking for any other refactoring opportunities, removing some comments that are now redundant, looking at, is there any more duplication that I should tackle? Well, actually, there might be. Looking at this tie score, I could probably use my new function score name here. But I think I might leave that as an exercise to you. Perhaps you can do that if you have time when you're refactoring. I'm going to start over now and do the refactoring again, but this time without my fancy refactoring tools. Sometimes you're working in an environment or language where you don't have that, and it's good to still be able to do the refactoring safely. So I'm going to show you the steps. I've got the code open here in Sublime Text, but I'm still flipping over to Rider when I need to run the tests. So the first step of the refactoring is just to highlight the code that you want to extract. So I'm just going to copy that into the clipboard. Then the next thing is that I would like to be able to keep track of the new method as well as the old code. So I'm splitting the view so that I've got the same file open twice, and I can keep looking at the original place where I'm using the code and the new place where I'm making the new function. I'm declaring a new function here, and this is really just a placeholder, and I'm naming it applesauce, which is the traditional name for code that you don't know what to name yet. And I'm just going to paste the code here. And now I just need to fix a few things up, like the indentation has gone a bit wonky, and I probably don't need that comment anymore. So now I need to look at this code and think, okay, I need to have a return value for my new function. It needs a name. It might need some arguments. What are they going to be? Well, the return value is going to be that tie score. So let's fix that. Get the type in the signature and return the thing. Okay, that's looking better. I don't think we actually need any arguments to this function. It's using the data member player1 score. Otherwise, it's all local variables. But we do need a name. So tie score seems to be the name we had before, so let's use that. Okay, so now I'm just running the tests. And running the tests here is not actually to run the test because I'm not calling my new method. It's really just to make sure I've run the compiler and everything's okay. So my new function is there, it compiles, but it's not being used. Then I turn back to the original place where I was wanting to put this extracted function. And I'm just going to comment out all of that code that I've extracted. I don't like to delete it straight away in case I want to refer to it or just need to be reminded what it looked like. I mean, all that is in version control, but somehow I prefer to have it there in a comment. So then I need to call my new function and see whether that actually runs the tests. So save, run tests. Yes, so my new function is now being used and the tests pass. So I can delete all of those commented out lines of code. And there, I'm done with the extract function. I'm going to do that one more time just to show you again. The endgame score. So first step, copy into the clipboard all the code you want in the new function. Second step, define a function with a dummy name, applesauce. Void, no arguments, just a placeholder, somewhere where you can paste that text. And then, just going to fix up the indentation. Remove anything that's totally extraneous, like the comment. And then scan this code. What's my return value? What are the arguments? Well, the return value is this local variable, which is a string, so I can fix the return type and make sure I return it. And then I could fix up any arguments. There aren't any arguments needed here. It's all just working on local variables or data members. Then I need a function name, endgame score, name it after what it does. Save, run the test or the compiler. Looks good. So now I can comment out the section of code that I think I'm going to replace, keeping it there just in case I want to refer to it. And then I can call my new function. Save, run the tests. Great, so that looks successful and I don't need this code here still to refer to. So that might look laborious when you've got a relatively straightforward extract like I had here, but if you've got something a bit more complicated, a few more variables, a few more more complex return type, then these sequence of steps is a way to do it safely even when you don't have refactoring tools. Now it's your turn. I've got this exercise ready for you to download and try out for yourself. I want you to identify paragraphs of code, use safe refactoring techniques to extract functions or methods, and then repeat for any other paragraphs you find in the code. And then all the time, assess, is the code better now? And did I do this refactoring safely? You've got a really good suite of tests that actually will tell you if you make a mistake, so run those often. Just now at the end of the session, it's your chance to reflect on what happens and what you've learnt that might be useful to you in your daily work. I'd like each person to write your own note outlining the important steps that you go through when you're doing extract function. What is important to remember here? When you're coding in your normal production environment today, see if you can find any opportunities to use extract function. I hope you'll be able to make your code more readable, easier to understand, and cheaper to maintain. Happy coding! This part of the video is meant for the facilitator who will lead this session on my behalf. I expect you're a developer on the team or a technical coach working with them. I'm just going to talk you through the parts of the session you'll lead and try and anticipate any difficulties you might face. If you haven't done this before, you should also go and watch my video, Guided Learning Hour How To. First, an overview of the parts that you're going to need to do with me. So I've got a connect at the start, just a couple of minutes, the concept or concrete part where we do a little exercise, checking we've understood what's going on here. Then there's a concrete practice, which is a coding exercise, which people will do in pairs. And then the conclusions, again, just a short little thing at the end so people can hopefully remember what it is they've learnt. So that connect activity, the purpose of this is just to remind people what they already know about short and long functions and why you might choose one over the other. And this is a 3 facts connect. That means that there's not supposed to be a long discussion here. You're just asking people for their ideas and you write down whatever they say. Don't try and evaluate it or come back with comments or you might ask follow-up questions if you don't understand the fact that they're trying to tell you. But this is not a discussion. This is just, reminding what we know. And then move on to the next part. The next little exercise that you need to facilitate, people are going to work in pairs to identify paragraphs in a piece of code. So the first thing you'll need to check is that the code is in the correct programming language for the group that you've got. My activity board uses C# and you can get a copy of my board by subscribing to my Patreon. If you don't have that or you need a different language, you'll have to do a little bit of work. First, check there is a translation for your language, and if there isn't, perhaps you could send me a pull request when you've created it. And then you'll just have to copy a screenshot of that onto your board. When you're actually facilitating this activity, you've got all these groups and little breakout rooms working on it, and you can see, if you zoom out on the activity board, you can see those boxes moving. And you'll know that people have basically done with the activity when the boxes stop moving. And that's when you can bring people back from the breakout rooms. You should, of course, also set a time limit so that they don't, so you've got time for everything in this session that you want to fit in. The next part that you need to facilitate is the coding exercise. And this is where you probably need to set up a project that they can easily open so they can get going with the activity quickly. Then the challenge for you is to make sure they stay on track. One thing that might happen is that one group finishes really quickly. They're already really good with their refactoring tools and it just takes them a few minutes and they've got this sorted. That is a really good sign for your group, but it might be a bit annoying if some of the other groups are nowhere near finished. What you should ask them to do, perhaps, is to do it again, faster with more shortcuts, so they can train fluency with the tools. Make sure that everyone takes a turn with the keyboard and using the tools. Another thing you can ask them to do is, put your tools away. Do the same refactorings without tools, the way that I showed it, so that they can learn the steps that you need to go through to still refactor safely when you don't have tools. And then there's the conclusions. Now, it's worth spending just 5 minutes at the end of the session, so cut short the coding exercise even if people aren't done. And get people just to reflect. What have they learnt in this session that could be useful to them in their everyday life? And that's the purpose of writing these notes. I hope that equips you with everything you'll need to run this session. And after you do this with your team, I'd love it if you would let me know how it goes. Leave a comment on the video. Until next time.